Now let us discuss about the updraft and the downdraft type fixed bed gasifiers. In the updraft type gasifiers is the simplest always the first type of the gasifiers developed. So in this type of gasifiers, it is easy to build and operate. The air enters below the combustion zone and the gas is drawn off the top. The updraft gasifiers achieves highest frequency as the hot gas passes through the fuel bed and leaves the gasifier at a low temperature. So the gas produced has practically no ash but contains tar and water vapor because of passing of the gas through unburned fuel. Hence the updraft gasifiers are suitable for tar-free feedstock, that is like fuels like charcoal. They are most unsuitable for high volatile fuels. The zones of various reactions are the combustion zone, the reduction zone, and the pyrolysis zone. So this is the working of the updraft gasifiers, which is on the left hand side of this diagram. Now we are going for the working of the downdraft gasifiers. So the downdraft type is the best suited for the variety of biomass. In the design forces, the raw products is to pass through a high temperature zone so that most of the unburned pyrolysis product, especially tars, can be cracked into gaseous hydrocarbons, thus producing a relatively clean gas. A recently developed downdraft type gasifier is given here. In this, we can see the different zone, the pyrolysis zone, the combustion zone, and the reduction where the biomass is and the air and every is air and is entering in the below and the gas or water in the upper surface. Now let us discuss about the fluidized bed gasifiers. Here we can see in this diagram this free board fluidized bed and a plenum, and there is a source where through biomass can be fed and air and steam is there, and there is a cyclone zone where the ash can be collected. A fluidized bed gasifier takes the advantage of excellent mixing characters and high reaction rates of gas solid mixture. A simple fluidized bed gasifier is a chamber with a bed of inert particles such as sand or limestone supported by a distributor plate. Here what happens here is, here the pressurized air is passed through a distributor plate. Thus, the velocity of the air is progressively increased till the upward drag of air on bed particles supports the entire weight of the bed. The bed is then said to be incipently fluidized and it exhibits fluid-like properties above the velocity called minimum fluidization velocity. This moving mass of solid is called as fluidized bed. The turbulence of the bed increases with the velocity of the minimum fluidization velocity. The fluidized bed is initially heated and externally close to the operating temperature. The bed material, usually sand, absorbs and stores the heat while the turbulence and mixing of the bed keeps the temperature very uniform throughout the bed. When biomass fuel is introduced into the fluidized bed, the high heat and mass transfer characteristics permits the rapid energy conversion at a particular isothermal condition. The high surface area available in the fluidized bed and constantly moving mass results in good conversion efficiency and lower operating temperature compared to fixed beds. The fluidized bed design produces a gas with low tar content but high value of particulate. The high exit temperature complicates the efficient energy